In the last activity, we explored how submarines use sound waves to see what's around them. In this activity, we'll use basic principles of ultrasound and resolution to design a system to map out objects inside a box. We'll use this as a model for how ultrasound sees objects inside the human body.
When students receive their boxes, the first thing they should do is make a grid on the top. They can measure the grid out by hand using a ruler, or they can use the graph paper provided. When making this grid, students should remember what they learned in the previous activity about resolution. The shorter the distance between samples, the better resolution the final images will have. However, this is a trade-off. If you cut the distance between samples by 1/2, you multiply the number of points by 4, and therefore taking measurements will take 4 times as long. The box designs that your students come up with will likely fall into one of 2 categories. In the first design, students cut slits across the grid. They can then use rulers to directly measure the depth at regular intervals along the slit. In the second design, students punch holes at each point on the grid. However, since they can't use a ruler to take measurements, they will have to mark inch markings on a chopstick and use that to measure the depth at each point. Whichever method the students use, remind them that this is only a model. In a real ultrasound device, measurements are taken using echolocation as discussed in Activity 4. After the students finish their locator boxes, the next step is to make their 3-dimensional terrains. These can be made out of any objects you have lying around the classroom. When selecting objects, it's important to consider their size, because any details smaller than the resolution of the locator box will not be able to be made out on the final map image. Once students have their terrains planned out, have them tape the objects securely to the piece of cardboard. This is important because the students don't want the objects to move around while measurements are being taken. After the students finish constructing their 3D terrains, they should place their terrains in another group's box for mapping. The group that's mapping the terrain should not look at it before it's placed in the box. To make a map of the terrain, the group must first take measurements at every point on the locator box. These measurements should be recorded in a grid. Once data is taken for every point, the students can make a map just like they did with the CT scan in Activity 3. They can use whatever color or shading scale they want, but it should follow some logical progression, for example, light to dark. After the students finish their mapping, they should understand that these model ultrasound devices are great for locating objects, but have limited use for determining an object's shape. In this example, the cardboard box was easy to make out because of its simple shape and large size. Other larger objects, such as the glue bottle, can have their shapes determined moderately well. However, finer details, such as the roundness of the cups, are lost completely due to the low resolution. Greater detail can be achieved by higher resolution, but remember that this will take the students much longer to complete.
In this module, we've seen how biomedical engineers use math and science to create technologies to see inside the human body. We've seen how density is important in X-ray machines. We've seen how math is used to put multiple images together to create CT scans. And finally, we've explored how sound waves are used to create ultrasound images. We hope that this module will help you inspire the next generation of biomedical engineers to create even better medical imaging technology in the future.